Let's keep talking about some properties of square roots. We've talked about multiplying and dividing them, but now we're going to add and subtract. So in order to add or subtract square roots, you have to look for like radicals, which is the same thing as saying like terms. So for example, 2 times the square root of 3 plus 5 times the square root of 3 makes 7 square root of 3's. So we're not adding what's inside the square root. We make sure that they have to match. So these two square roots have to be matching. And then we add the coefficients out front. 2 plus 7 makes the 7 square root of 3's. This is just like 2x plus 5x is 7x. Right? That we're not adding the x's, we're adding the coefficients in front. The same works for square roots. So let's first answer a question. And this might also, sort of tie into why these have to match. Does the square root of 9 plus 16 both together under the square root equal the square root of 9 plus the square root of 16? This brings up a good point that you have to look for how long this square root line is, because if it stops at the 9, then the 16 is not part of it. And also when you're drawing your square roots, I want to see that they actually go over what they're supposed to go over and not extend further or go too short. So this is really an order of operations question. This first one says do the addition first. That'd be square root of 25. And we want to know, is it the same thing as the square root of 9 plus the square root of 16? Well, that would be 3 plus 4. And no, of course, 5 does not equal 7. That these are not the same. So what this brings up is that square roots do not distribute over addition subtraction. They only distribute over multiplication and division. And the reason is because they're really exponents. Exponents do the same thing, where if I did, let's just say 1 plus 2 squared, actually, yeah, that works, is not the same thing as 1 squared plus 2 squared. And we did a lot of foiling when we got an addition being squared, because this would be 3 squared, and that's not the same thing as 1 plus 4. Right? So square roots behave just like exponents because they really are an exponent, which we're going to see later in chapter 6. But for now, just know that we can't split up addition or can't join together an addition of square roots unless they're like terms. All right, so what the homework's going to look like, it says add or subtract the following square roots, simplifying them as much as possible. So first we look to see that they're like terms, which they are. Now in front of this first square root is like an invisible 1. So it does have a coefficient, because that's what we need to add, is 1 plus 9 makes 10. And then square root of 14 just stays square root of 14. We don't add those, we're just adding the coefficients. Now the other thing to check to see is if there's a perfect square that goes into 14. Remember, that's what we mean by simplifying a square root. Simplifying involves looking for those kind of perfect squares that go into there, but there's none in that one. Let's try the next one. So 2 square root of 12 minus 3 square root of 12. Well, the square roots match, so that would be negative 1 square root of 12. Now, there's a couple things that we need to sort of fix in this. One is WebWork has this weird thing where it doesn't think that's simplified because it would just want the negative. It doesn't want you to type that 1. So that's something, like, really, if this were like the midterm or the final, I wouldn't care whether you put the 1 there or not, but WebWork doesn't like a 1 as a coefficient. It thinks that you shouldn't type that. The other problem, though, is that 12 has a perfect square in it. It's not really a problem, it just means we need to do another step, because 12 is 4 times 3, and square root of 4 simplifies. So then that would be negative 2 square root of 3. Because the square root of 4 is 2, and then square root of 3 doesn't simplify. And of course, the negative we keep around. Good. Next one, these are not like radicals, but we can simplify, and we should simplify the square roots before, and then maybe after we simplify them, maybe they will join up. Maybe they will be like radicals. So the reason these can simplify is because 4 is a factor. 4 times 2 makes 8, and 4 times 3 makes 12. And so we can simplify these because the square root of 4 simplifies. So that would be 2 square root of 2 is the same thing as square root of 8, plus 2 square root of 3, right? Because square root of 4 is 2, square root of 3 just stays put. Now these are not like radicals, which means that we are done simplifying. That's the furthest we can go, so we're just done. But we still, it was important to simplify the square roots, but now they don't match, so I can't add them any further. Let's see about part D. In part D, again, we look for factors that are perfect squares. Now 54 is 9 times 6, and square root of 9 simplifies. So remember when we talk about looking for perfect squares, it's really just 4, 9, 16, 25 that I'm looking for. And 9 goes into 54, and 4 goes into 24. So this would be square root of 4 times square root of 6. So after we simplify these square roots, we get 3 square root of 6 minus, from the original problem, 2 square root of 6. And now that we've simplified, now these are like radicals, so we should do 3 minus 2 and get 1 square root of 6. But again, WebWork doesn't want us to type that 1. So it's just square root of 6, which we would type into WebWork as SQRT of 6. Great. All right, let's see if we got these by doing a few more, making sure. So we check, are these like radicals? Yes. And if they are, we just add or subtract the coefficients. So this would be negative 4 square root of 7. 2 minus 6 is negative 4. Part B, these are not like radicals, so we can't do anything else. They're already simplified. There's no perfect squares that go into 10 or 11, so that's just done. Part C, square root of 5 is simplified, but square root of 25, square root of 25 goes into 75. So square root of 25, square root of 3, because 25 times 3 makes 75. So this would be square root of 5 plus 5 square root of 3. And then that's it. So that is simplified, because these are not like radicals. But we could do one step of simplification to get that that perfect square out of 75. All right, last one. I'm seeing 4. 4 times 3 makes 12, and 4 is a perfect square. 4 also goes into 48. It'd be 4 times, 12. I don't know why I was... Oh, I think I was worried about the other factor of 4. So because 4 is a factor twice, it actually turns out that we could have factored out a 16. 16 goes into 48. So if we saw that, it might be quicker, but I can also just view it as 4, 4, and 3. So this would be 2 square root of 3 minus 2 times 2 times square root of 3. All right, so the first one, square root of 4 is 2, square root of 3 just doesn't simplify. Square root of 4 and another square root of 4 make 2 times 2 and then times square root of 3. And again, if you had seen that the 16 goes into 48, you would have just not needed this extra step of work. So final answer is negative 2 square root of 3.